A very warm welcome to all. Today I'm going to talk about the friction and its applications. So we know friction is there everywhere, and one of the very important applications, and there are a variety of applications actually. So before we get into the friction, I'm going to tell you some situations. Situation number one is: have you ever stepped on a banana skin which is lying on the ground? Situation number two: have you ever stepped on a wet floor? Have you ever got slipped? And situation number three: have you ever played carom board? And have you ever applied powder? So, in all these three situations, you may think that something is being introduced in between the mating surfaces, the two mating surfaces, but actually, it is not that something is being introduced, it is actually something is removed, and that something is called as the friction. So, Newton's second law says that F is equal to ma. Suppose take this object. So in this object, suppose if I myself Mutram, I'm applying a force on this object. So suppose if I apply a very little force, so this object will not move. So we cannot say that because the acceleration is zero, we cannot claim that I have not applied a force. But I have applied a force, it is not moving. The reason is there is an opposing force, and this opposing force is called as the frictional force. So suppose if I apply 1 Newton of force, the friction force will also grow itself to 1 Newton. Suppose if I apply to 10 Newton, this friction force will also grow to 10 Newton. Suppose if I apply a greater force, then beyond which this friction cannot develop itself, so automatically this object will start to move. So this force of resistance to motion is called as the frictional force. And there is a direct relationship between this frictional force and this normal reaction, this weight force, this normal reaction, and that is the friction force is directly proportional to the normal reaction. So this is equal to mu into this normal reaction. This mu we refer as the coefficient of friction, the coefficient of friction. So why this friction actually develops is that if we zoom this contact surface to 1000 times, so we can actually see that there will be some surface irregularities, there will be some protrusions. So because of these protrusions, because of these irregularities, upon applying a force, there will be some resistance offered by this protruding surfaces. So obviously what will happen, this will resist the motion. So in atomic level, if we see, there's a lot of electrical interaction between the atoms and molecules, so that also a part of the friction. So suppose if an external force is applied, the retarding force is called as the force of static friction if the body is at rest. Suppose if the body has started to move, then the retarding force is called as the force of kinetic friction, the force of kinetic friction. So if we draw a graph between the applied force and the friction force, so what will happen is, upon applying the force, the friction force will also develop itself, but beyond a certain point the friction force cannot develop itself, so obviously it will reduce. So after the motion has started, the friction force value reduces a little. So this region is called static region, and this region is called as kinetic region. So in this region, we call this mu as the coefficient of static friction, and in this region we call this mu as the coefficient of kinetic friction. So if you want to find out that coefficient of friction, we can actually draw the free body diagram, and we can find out the relationship between the coefficient of friction and this inclined plane angle alpha. So this mu is equal to tangent of the alpha. Alpha is the angle inclination of this inclined surface. So whereas the beauty is, this mu does not depend upon the mass of the block, because the mass is being neglected, the gravity is neglected, and also it does not tell us any information about the surface area of contact. and also it does not tell what is the mass of the object, what is the surface area of the object. So it depends only on the nature of the material, the nature of the contact surfaces. So it depends only upon the sliding surfaces, the nature of sliding surfaces. So I'll tell you an example. So it means that it does not depend upon the mass means, so in an inclined plane, if there's a car and if there's a bike, and if there's an angle alpha, the road, suppose if we can able to increase the angle alpha, both the bike and the car will start to slide at the same angle. So that is the beauty. So it does not depends upon the mass of the block. It does not depends upon the surface area of contact. It depends only upon the nature of the material.